In this video, we will study first shifting theorem. Accordingly, if Laplace transform of f of t is phi of s, then Laplace transform of e raised to minus at into f of t is phi of s plus this a. This can be easily proved. This left hand side equals, by definition, integral from 0 to infinity e raised to minus st into this e raised to minus at f of t dt. After simplification, integral from 0 to infinity e raised to minus s plus a t f of t dt, which we know is phi of this s plus a. We will see how to apply this first shifting theorem for solving problems on Laplace transform. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. In this first shifting theorem, all we have to remember is we have to replace this s of phi s plus a. For example, we have Laplace transform of sin at equals a upon s square plus a square. If we want to find Laplace transform of e raised to minus bt into sin at, all we have to do is replace this s by s plus this b. So this will be s plus b whole square plus a square. Obviously, for Laplace transform of e raised to plus bt sin at, we have to replace same s by s minus b instead of plus b. So it becomes s minus b whole square plus a square. We have Laplace transform of cos at is s upon s square plus a square. Therefore, Laplace transform of e raised to minus 2t cos 3t according to first shifting theorem will be replacing this s by s plus this 2 upon s plus 2 whole square plus a square, means this 3 square, which will be s plus 2 upon s square plus 4s plus 4 plus 9, which will be s plus 2 upon s square plus 4s plus 13. How to find Laplace transform of e raised to 2t sin raised to 4t? First we find Laplace transform of this sin raised to 4t, which is Laplace transform of square of sin square t. But sin square t is 1 minus cos 2t upon 2 whole square, which is 1 upon 4. Laplace transform of 1 minus 2 cos 2t plus cos square 2t, which is 1 upon 4. Laplace transform of 1 minus 2 cos 2t plus, for cos square 2t we write 1 plus cos 4t upon 2, which is 1 upon 4 into Laplace transform of this 1 and this half 3 upon 2 minus 2 Laplace transform of cos 2t plus half Laplace transform of cos 4t. This we further write as 1 upon 4. Laplace transform of 3 upon 2 is 3 upon 2 into Laplace transform of 1, which is 1 upon s minus 2. Laplace transform of cos 2t is s upon s square plus this 2 square 4 plus half. Laplace transform of cos 4t is s upon s square plus this 4 square 16. Now by first shifting theorem, this Laplace transform will be 1 upon 4 into 3 upon 2 into we have to replace this s everywhere by s minus this 2. So here it will be 1 upon s minus 2 minus 2 s minus 2 upon s minus 2 whole square plus 4 plus half s minus 2 upon s minus 2 whole square plus 16. This can be further simplified to get more simplified answer. We have to find Laplace transform of hyperbolic cos 2t into cos 2t, which is L of hyperbolic cos 2t will be from above formula half e raised to 2t plus e raised to minus 2t multiplied by this cos 2t, which will be half Laplace transform of e raised to 2t cos 2t plus Laplace transform of e raised to minus 2t cos 2t. First we find Laplace transform of cos 2t, which we have s upon s square plus square of this 2, 4. Now by first shifting theorem above, this Laplace transform will be this half into, we will replace each of these s by s minus this 2. So this is s minus 2 upon s minus 2 whole square plus 4 plus s plus 2 upon s plus 2 whole square because of this minus 2 here plus 4. This can be further simplified to get a more simplified answer, s cube upon s raised to 4 plus 64. Let us find Laplace transform of t cube into square of hyperbolic t, which is L of t cube into square of hyperbolic sine t from this formula above is 1 upon 4, which is square of this half into e raised to t minus e raised to minus t whole square, which is 1 upon 4 L of t cube into expansion of e raised to t minus e raised to minus t whole square is e raised to 2t minus 2 times e raised to t into e raised to minus t is 1 plus square of e raised to minus t e raised to minus 2t, which is 1 upon 4 into Laplace transform of e raised to 2t into t cube minus 2 times Laplace transform of t cube plus Laplace transform of e raised to minus 2t into t cube, which is 1 upon 4 again by first shifting theorem above. This is 3 factorial upon s minus this 2 whole raised to this 3 plus 1, which is 4, which is according to the formula Laplace transform of t raised to n is n factorial upon s raised to n plus 1 minus 2. Laplace transform of t cube will be 3 factorial upon s raised to this 3 plus 1, 4 plus Laplace transform of e raised to minus 2t into t cube will be 3 factorial upon s raised to 4, but s will be replaced by s plus this 2 whole raised to this 3 plus 1, 4. This can be further simplified to get most simplified answer. Find Laplace transform of e raised to t sin 2t sin 3t. We have this sin 2t sin 3t by defactorization formula is minus half cos of 2t plus 3t 5t minus cos of 2t minus 3t cos t. So minus half Laplace transform of cos 5t minus cos t will be minus half s upon s square plus this 5u square 25 minus s upon s square plus this 1 square 1. Now this will be equal to, by this first shifting theorem minus half times, we will replace each of these s by s minus 1 because here a is 1. So s minus 1 upon s minus 1 whole square plus 25 minus s minus 1 upon s minus 1 whole square plus 1. After simplification, this will become minus half times s minus 1 upon s square minus 2s plus 1 plus 25 minus s minus 1 upon s square minus 2s plus 1 plus 1. This will be minus s minus 1 upon 2 into s square minus 2s plus 2 minus s square plus 2s minus 26 upon s square minus 2s plus 26 into s square minus 2s plus 2, which finally becomes 12 into s minus 1 upon s square minus 2s plus 26 into s square minus 2s plus 2. A thing to be noted here is whenever a function comes with hyperbolic cos or hyperbolic sine, it also comes with terms of e to the power t and e to the power minus t. Therefore, the function f of t gets multiplied with e raised to at or e raised to minus at, and hence we get to apply first shifting theorem. Laplace transform of e to the power minus at f of t is phi of s plus a, and Laplace transform of e to the power plus at ft is phi of s minus a. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.